All right. Hello, everyone. My name is Herschel Parikh, and welcome to the How to Explore, Visualize, and Analyze Data on Tuva. All right. So we'll just wait another minute or two to let some of the people who may be just getting their GoToMeeting set up come online. So we'll start in about another minute or two. Um, in the meantime, as we're going through the webinar, if you have any questions, we'll leave them towards the end, but feel free to note them down in the questions tab in the control panel, and we'll get to them towards the end of the webinar. So that we just want to make sure that we're able to get to everyone's questions in the time that we have for the webinar. Also, if you are not already following us on social media, if you're on Twitter, make sure you reach out and follow us on at Tuva Labs to get the latest updates on features, on new updates on releases, things of that nature. We're also making these updates available on Facebook and on LinkedIn, so you can find us on any of the social media websites if you are on social media, and you can stay updated on the latest features that we release or on a week-to-week basis. All right, we'll give it another minute. We're testing out different times to host these webinars because we do have a community of educators from really around the country and parts of the world. And so, this is 6 p.m. Eastern, 5 p.m. Central Time, 3 p.m. Western Time, and then we technically also have teachers coming in from Europe and even from Asia. So over the next few weeks, we'll also be running, I think, this webinar again at a different time for those who are not able to make it at this hour. Okay. All right, so I think we can start. You want to utilize the entire hour that we have. So welcome once again to the How to Explore, Visualize, and Analyze Data on Tuva webinar. And my name is Herschel, and I am one of the co-founders of Tuva. And as I already mentioned, if you're active on social media, you can find us on Twitter, Facebook, or LinkedIn to get the latest updates on new data sets, new features, things of that nature. Come say hi if you have any issues. We're happy to get back to you on any of these sites. So let's get started. So the goal of the webinar today is to spend some time showing you and going over how to explore and visualize different kinds of graphs and charts using the Tuva tools. And so if you're on Tuva today, you probably saw a couple of things. We actually just a couple of days ago released a pretty major update on our filter on the Tuva datasets. So here it is, just for those who haven't gotten a chance to see see the new filter bar. So now you'll be able to filter for a specific data set or lesson by subject area, by grade level, by the size of the data set. So if you're looking for a smaller size data set, you're just getting this started with your students. Then you want to start off with a simpler data set versus if you're looking for a larger data set, so you can search by the size of the data set. For the science teachers in the United States, now you'll be able to actually filter and find data sets that are related to specific NGSS standards. And so this is just an initial list of middle school standards, but we'll be adding more of these NGSS standards. And then for the international teachers from around the world, really, we'll be adding data sets in Spanish and in Arabic as well. So a really exciting update to be able to help you find the data set you're looking for as quickly as possible by filtering for it, or you can always search for it as well. So let's get started. I'm going to go to all the free data sets, and we're going to spend most of the webinar today looking at one data set, just so that we can spend some time really diving into the data set. So this is the Census School data set, and I'll tell you more about it. So the Census at School is an international project. Currently in the United States, it's managed by the American Statistical Association. It started off in New Zealand about 11 years ago, and now nearly 7-8 countries, New Zealand, Australia, South Africa, Ireland, UK, and many others, have a pretty big Census at School project where students get an opportunity to take a questionnaire, and they answer questions about themselves. And so here's the basic background in Census at School. So here's a US Census at School questionnaire. And so students go through and answer these questions about themselves. What are they, how important they feel about specific issues, their arm length, their foot length, their age, their gender, different aspects about their favorite seasons and things of that nature. And this is a great survey data set that one can dive into. And it's a really fun data set for students because for many of them, they can upload this data on Tuva and they'll be analyzing and visualizing and doing activities using the data that they've collected. So this is a fun data set to do, especially in the context of the math or science classroom, where your students collect the data from the census project, and then they actually are able to then do lessons around it. And it makes for a really fun activity because they're looking at data about themselves. So there's a sense of relevance to it, which is really, really critical. So that's a little bit about the Census at Schools. And so here we are on, here's the data set on Tuva. And as some of you already know, we've got, in this particular Census at School data set, we've got each one of these circles represents a data point. And so I think the first thing to do before we dive into any of this is to really just make sure we understand that what does each one of these points represent. And here is the table view. So this expresses this data set in a tabular form. So as you can see, so the columns, there's different columns: gender, age, height, foot length, arm span, and each case describes the responses of one student that took the survey. So in this case, we have 500 data points. And so this particular table then gives us data about 500 responses. So 500 students responded to the survey, inputted their answers, and that's the data that we have in front of us. And the reason why we're spending some time on this is because even for your students, it's important for them to understand and get a grounding of, well, what exactly does each data point represent? Is it a person, which the way it is in this case? Is it a car? Is it a country? Is it a planet? Is it a year? So it's really important for any data set that you or your students come across to ask the question, what does each row, or in our case, what does each case represent? And so here, if you were to highlight case 155, like such, you can see that that individual, that student is right here. Let's do another one, highlight case 188, and that individual is right here. So that's important to make note of. And then we also, as you know, Tuva sort of, we don't represent the data in a tabular form. It's actually a pretty tricky way or difficult way for students to dive into the data. So what we do is instead, we actually have what's called a case card, which takes the same data from the table, but expresses it in a case card format. So it's a card format, and you can sort of go up and down like this. And as you go up, you can see that that particular student is represented in a random point in the graphing area. So that shows you a little bit of the connection between the table view, right here, case 181, the card view, and that particular data point on the graphing area. All right, so with that then, just to get some terminology, so this is, we call this a case card, this is a table view. Right up here is the toolbar. And then right here at the bottom is what we call sort of the help bar, which is it gives you a background information about the data set, gives you a set of glossary, and a tutorial video in case you or your students are unable or need a quick review on how to analyze the data. Okay. So with that, let's start digging in. So we're going to take, let's take the age attribute right here, and let's plot it on the x-axis. So we're going to take the age attribute, we're going to plot it on the x-axis. All right. And so here's what we find. We have in our 500 respondents, students as young as 8 years old, all the way out to 19. So that's sort of the that's sort of the range of ages that we have. And you can sort of expect, as you would think, that, you know, there's all the ages are at whole numbers, 8, 9, 10, 11. There's this one student who inputted 11 and a half, but most of the students then 12, 13, 14, 15, and so on. So one of the things that it's useful to do is say, well, okay, you know, age in this particular way is treated as a numerical attribute. So it's a continuous variable, and it's treated as a numerical attribute. But what we want to do is we want to find out how many students are age 17 in this data set, or how many students are age 12 in this data set. So in order for us to do that, what we have to do is to treat this attribute, the age attribute, as a categorical attribute. So we're going to go here to the filter, to this little icon here, filter icon. And here, it's sort of a card behind the case card. It's sort of a, let me do that again. So when you press the filter button, it's the card flips and gives you details about the age attribute. And so type, as we saw, it's a numerical attribute, and it's being represented in an ascending order, and it's got its minimum value at 8 and maximum value at 19. So one of the first things we want to do is we want to treat this as a categorical attribute. So I'm going to choose categorical instead of numerical, and watch what happens. And now each of the ages is being treated as an independent category. And I can then use this toolbar function, go to this icon, press, hover over the count, and click count by category. And now I have a basic idea of the number of students in each particular age. A couple of things to notice. So let's go ahead and get a percentage. Okay. Let's go ahead and get a count. One of the things that you'll notice right up front is that there are, let me do this. There are some values here. There's 16 students on the right side. There's 16 students where the value is missing. And so it's important to recognize that not every case, not every data point might have all the values. In this case, 16 students chose not to answer this question, and so we don't have we don't have the data for their particular age, and so we have to remove these data points from our exploration. So, and a way to notice that is I jumped ahead, but the way to notice that is if I look at the age attribute and we can treat it as categorical. Uh, this panel is coming in the way, so I'm going to minimize it. So we saw that there is the 16 missing values. And we have 484 students that have responded to the age attribute. So let's do a quick thing. Let's click on gender. And as you'll see in the case card, there's a color for each attribute. So when we clicked on gender, what happened? Each of the dots changed its color to green or to orange, and that's the way you see it here. So you have females as orange and males as green in this case, and we can then actually grab the gender attribute, place it here on the y-axis, and now we've sort of split our plot area into two groups. We've got all the males and all the females. And again, we've got 16 values that are missing. Okay, and we can get we're still getting the sum. We're still getting the count for each one. So a large, we've got basically 90 students that are males and 93 students that are female that are at age 17 in this particular data set that we have. So far, what we've really done is we've basically just been maneuvering dot plots. We haven't really done a whole lot of other kind of graph areas, but even with the dot plots, what you can see is that there's a lot that we've already been able to figure out. That in the case of age, 16 values are missing, and plenty of students, lots of students are at the age are of age 17. So let's do one more thing now. Let's take the heights. Let's take the height attribute and plot it here on the y-axis. Actually, I'm going to plot it here on the x-axis. And I'm going to grab the age gender again. I want to plot it here on the y-axis. Sorry about that. Right, so that's what I wanted to do. So now we've got, again, a dot plot. This is sort of in where we've got height on the x-axis, and we've got the gender on the y-axis. So we've got two distributions, one for the heights of all the females and one for all the heights of all the males. And again, you notice that 49 values are missing. So initially we had 16 students who did not choose to submit an answer to their ages. And in this case, we have 49 students who decided not to include the answer to their heights. So it's important to note if there's any missing data in our data set. Again, go back to the count function, get to the mean, and so now we can get a quick sense of what is the average height of all the males in the data set, and what is the average heights of all the females in the data set. And now we can do some comparisons and see it's 171 centimeters in this case, and for females, it's 160 centimeters. So again, we're still creating mostly scatter plots and dot plots. We haven't done any of the other ones, but we're still able to learn a lot about what this data is about, right? In terms of its mean, its distribution, um, and what the overall distribution looks like. So let's do a reset, and let's reset the environment. One of the things that you'll notice also is just how easy it is for you and the students to be able to explore the data. So if the student makes a mistake, it's just reset it, or there's a way to, in fact, undo as well. And so if you make a mistake in creating your graph or in exploring the data, it's very easy to start over again. And one of the things that we recommend in terms of learning is that for your students to give them an opportunity to explore the data in many different ways, to allow them to make mistakes, because it's very easy for them to reset the environment and start all over again. And in many cases, what you'll find is that for one specific question, there are lots of different visualizations, and there's no one right answer. So allow students to come up with different kinds of visualizations as part of the learning when it comes to creating different kinds of graphs and charts for the data that they have in front of them. Okay, so let's do let's go back to let's sort of do one new data new kind of graph type, which is a box plot. So we're going to take the height on the y-axis. We're going to create a box plot. So I'm going to go to box, and I'm going to create a box plot. And in fact, what I'm going to do is I'm going to split this. So what I'm going to do is I'm going to bring it back here as such. I'm going to go back and put the gender. And so as we would expect, we now have two box plots for heights. We have one for females and we have one for males. And the box plot, as you know, when you hover over it, it gives you the 5-number summary. So we've got quartile 1, quartile 3, median, the interquartile range, the minimum, and the maximum. And we have sort of three different kinds of box plots. We've got the regular box plot. You can have a box plot with outliers. So let's see how the box plot looks with specific outliers. I'm just going to color it again so it's easier to see. And so these are the outliers in the males. We've got 1, 2, 3, 4, 5 outliers below the lowest point, below the lowest data point, and we've got one outlier up here. And then we've got some outliers for the females as well. And so this is a way to, if you're covering box plots, how does the outliers impact and what does the outlier look like? So if you hover over here, you'll see the lower whisker is 137. So anything below 137 centimeters is going to be considered an outlier. And so in this particular case, 136, 127. So the lower whisker is your cutoff point so that any data point that's below the lower whisker of 137 centimeters is going to be an outlier. Similarly here, anything above the upper whisker of 202.5 centimeters is going to be an outlier. And so here we have this data point that is 203 centimeters. And so this particular student is an outlier when it comes to their heights. In the case of box plots, as you may recall, what the box plot shows you is it splits our data points into the bottom 25%, the middle 50%, and then the top 25%. So let's do that. So let's create a box plot and dot plot. So it brings all the dot plots out and puts them in this manner. And we can use actually the dividers. The dividers allow us to see this where, and I'm going to do percentage. Okay, so I can move these dividers, and what I know is that anything below quartile 1 is going to give me the bottom 25% of the data, and then anything above quartile 3 is going to give me the top 25% of the data, and the middle is the middle 50%. And similarly, then I can do this here. The bottom 25% approximately, and then the top 25%. So because the dividers are jumping in larger groups, it's hard to get it exactly to 25%, but approximately it will be 25%. So the box plots, again, allow the data inside the box is the middle 50% of all the heights for males and for females. And then anything below the first quartile is the bottom 25%, and anything below the third quartile is the top 25%. So we have three different kinds of box plots for students to review the 5-number summary and to be able to review and interpret how to interpret box plots. Let's move on to the third one, which is let's do histograms. So histograms, then I'm going to press histogram. So what's going to happen is the box plots are going to go away. Turn off the dividers. Done with them. And what the histogram does is that it takes all the data points, all the heights, and it bins them. It creates an automatic set of bins. And so how do you know what the bin size is? So what the histogram has done is it took all the dots, binned them into bins of 20. So we've got 120 centimeters to 140 centimeters, 140 centimeters to 160 centimeters, 160 centimeters to 180 centimeters, and so on. And now you can see the distribution of the number of males and females in this particular bin. So the histogram allows you to take a numerical attribute, which is heights in our case, and bin them in different buckets. So we've got buckets, if you will. And so you can sort of say just by eye that the highest number of students are between 160 to 180 centimeters, and same thing with males and females. Both of them, the histogram is the bar is the highest at 160 to 180 centimeters. Now, what happens? How can I change the size of the bin? So, what if I don't want it to be 20 centimeters bin size? I want it to be 10 centimeters. So I can then press the plus button here. And what it does is that it, in fact, decreases the size of the bin and increases the overall number of buckets. So we've got now the bin size, the bucket size has gone down to 10 centimeters compared to 20, but we now have more buckets, right? And that is why it's a plus sign. And now you can see that the number of females, the high is 160 to 170 is the highest, but the number of males it's from 170 to 180. And that's why it made sense intuitively that the mean height of males would be bigger than the mean height of females. So this is a sort of an intuitive way to connect the histogram to your box plot in the case of the median. Or when we did the mean in the scatter plot, it's a way to sort of connect the two and say that, would you expect this to be the case? Yes, if I saw this, right? If I saw this, then I would expect that the mean height of males would be greater than the mean height of females. And similarly, so we're looking at heights, but we can do something similar for the foot length and the arm span. So if I replace the height with foot length, it moved over, the axes changed to the foot length, but again, I'm able to compare the foot length of males and females in centimeters, and similarly, I can also compare the arm spans. So whichever one, this is just an example of what you can do in terms of creating histograms specifically for numerical attributes, and you can see the distribution of the heights of males and females. All right, so let's reset the environment. And so we've covered so far scatter plots, we've covered box plots, we've also covered histograms in this case. And so now let's do something fun. So there's always an interesting question to ask, is there a relationship between your arm span and your height? So I'm going to take the arm span, I'm going to place it on the x-axis. I'm going to take the height, place it here on the y-axis. And so here it is. And so a really great math activity around functions and slope is to ask the students to say, okay, here's your distribution. Here's sort of how your scatter plot is when you plot the arm span on the x-axis and the height on the y-axis for 500 students. Now, using your y equals mx plus b formula, if you will, let's take our movable line and let's make a prediction. Let's go out and connect two over dots, maybe something like this. And the students, we can ask the students, okay, well, take two existing dots, take two existing data points from your distribution, and let's come up with a y2 minus y1 over x2 minus x1, that the entire sort of your finding the slope formula, to come up with your own equation to predict the height when you have your arm span. So your y is height, your x is arm span, and you have to figure out your slope, and you have to figure out your y-intercept. And that's a great way to get them thinking about, well, what 2 points are they going to use in from this data set that they have? And then they can compare it with the least squares line, which is the actual relationship between arm span and height in this example, right? So the blue line is the actual formula, the line of least squares line of the relationship between arm span and height. And the students can compare their responses. And then I think one thing to ask them is, well, in this case, we see that there's some sort of association, right? That if your arm span, if you have long arms, then there's a good chance that you're going to be taller, and you can almost, using this equation, figure out if you have an arm span of X, then what would your height be of Y using this formula. Watch what happens. And this is a great activity as well. Watch what happens when I replace the height with the foot length, right? So what happens is there a similar kind of relationship when I plot the arm span on the x-axis and the foot length on the y-axis. So let me do that and see what happens. What happened? What you saw is that the data points are much more scattered when it comes to the foot length compared when on the y-axis and the arm span on the x-axis. And what that suggests is that the association, the relationship between arm span and foot length is weaker compared to arm span and length. And you can sort of see that again by your least squares line. So again, a great way for students to do their units on y equals mx plus b and coming up with your own equation using two coordinate points and being able to see how close their equation is to the real equation. And what does that suggest about the relationship between the arm span of an individual and their foot length compared to the arm span and the height. So it sort of gives you an idea of how to use the movable line feature as well as the least squares line feature. All right, so let's reset our environment again and start doing something more fun, which is, let's grab the favorite school subject. So we have an attribute, we've got a number of attributes here. We've got their age, gender, which we've already looked at. We've got their heights, foot lengths, arm spans. How do they travel to school, right? So we have, we've got the students inputting their responses to how they travel to school. How much time does it take for them to reach the school? What is their favorite physical activity? We've got a couple of sort of rating questions where how important do they think it is to save energy? And so we've got different data sets here. This is another numerical attribute going from 0 to 1,000, where 1,000 is really important to 0 being not very important. Similarly, how important is internet access? So again, you've got 0 as being not very important to students, to 1,000 being very important. Their favorite subject area, their favorite subject in school, how many hours of sleep they get at night during their school night, and lots of other sort of different attributes. And this is, again, just a sample from the questionnaire that I showed you earlier. So there's lots of interesting data to deal with. We've just taken a sample of the questions and made a data set here in collaboration with the American Statistical Association. So with that, let's take the favorite school subject and let's work with that one. So we're gonna take the favorite school subject attribute. We're gonna grab it here and put it here on the x-axis. And so, as you would expect, they all organize themselves into different categories. We've got art, we've got computers and technology, English, geography, history, languages, mathematics and statistics, music, other physical education, science, and social studies. So this is the sort of this is sort of the distribution. And as you noticed right away, 62 students in this case chose not to answer this question, and so we have to keep that in mind. Um, and so before we do anything, let's take the school hours, sleep hours during school night, which is just attribute right here, and we're going to place it here on the on the y-axis. So that's how it looks, and we're going to create a bar chart. And so now the thing about the bar chart is in Tuva we actually have three different kinds of bar charts. We've got a regular bar chart, we've got what we call the stacked bar chart, and we've got what's called the stretch bar chart. And I'm going to go through these fairly quickly. So I'm going to create a bar chart where we have school subject and we've got the school hours, how many hours of sleep did they get during a school night. And so what that did was it took each individual data point, each individual student that answered this question, and it created a bar for it. So you can sort of tell, well, which student in this particular case gets the highest amount of sleep and the favorite school subject is history or art or geography or things of that nature. So in this case, what you'll see is that in Tuva, a bar chart allows you to create, it treats each individual data point and turns it into a bar and places it right next to each other. So in this particular context, it's not very helpful to sort of look at this, but to give you an idea of this is how a bar chart is treated in Tuva. What is more interesting, it's doing a stacked bar chart. So let's go ahead and create a stacked bar chart. So what it does is that it puts all the students who have their favorite subject areas in these particular categories and stacks them on top of each other. And here I'm actually going to remove the color and we'll see the data points here, right? So we've got the highest is in mathematics and in there's science, and these are again sleep hour school per night. So let's remove it, and what we get is the number of students now. So we've got 70 students that have their favorite school subject as math and statistics. We've got 46 students that has favorite subject as art. We've got 60 students as their favorite subject as science. So we've we're able to create a simple bar chart to be able to say how many students have a specific subject area that's their favorite. And so the stacked bar chart allows us to do that. And then if I create a stretch bar chart, so notice what happens. So we're going to create a stretch bar chart, and we're going to color it by gender. So the stretch bar chart treats each category to 100%, and then in this case, we're coloring it by gender, so it gives you the distribution of what percentage of all the students who indicated that their favorite subject was art or English or mathematics are males or females. And so here you'll see some things that some of it may surprise you, some of it may not. So in this case, in the case of art, 82% of almost 83% of the students who indicated their favorite subject area was art, 83% were females. And in the case of computer science, computers and technology, 78% were males and 22% were females. In the case of math and statistics, there's 57% were females and 42% were males. In the case of language arts, English, 67% were females and 33% were females were males. So this is a great way when you talk about proportions and being able to do percentages with your students. And these are Common Core, grade 6, grade 7 standards. These are wonderful ways to get your students to start thinking about percentages and ratios and fractions and things of that nature. There's really the sort of the crux of the beginning of algebra by using these kinds of activities. And of course, you can come back on Tuva and find the activities that go through these topics. But even just visually, getting them to understand the concept of a ratio, getting them to understand the concept of a fraction with a stretch bar chart is a great way of doing that. Where 8 out of 43, 8 out of 51. Let's get the count here so that we get this right. So here, 8 out of 51 was the fraction for the number of females that have their favorite sort of subject is gym, or in the case of math, 30 out of 70 are females, and then 40 out of 70 are males. And so the stretch bar charts are really just an ideal way to look at categorical attributes and percentages of breakdown for across different categories, across different groups. So in this case, we're looking at subject area, and we're looking at gender, and we're looking at the number of students that fall in these different categories, in these different groups, art and males, or geography and females, things of that nature. So this is sort of the stretch bar chart. Now, one really powerful feature to use is there are many times where we want to look at a specific subset of the data. So in this particular case, let's say we only wanted to study all the females. So how would we then filter out that data here in the Tuva environment? So again, we can use two things. We can do it two ways. So let's actually go here, see the filter button here, and we can say filter by. So I want to filter by the gender. So I'm going to click on gender, and then so it brings me here. And here I've selected both females and males. Well, what happens if I unselect the males? So if I unselect the males, you'll see all the males, all the greens go out and be removed from the graphing area. So what you see here again is all the orange, which is the females, 247 males have been filtered out. And now we can do all of our exploration for just the females. And so this is, again, another great way where if you want to ask your students about, if you want to split them into different groups, some of them looking at just male data, some of them looking at only female data, this is the one way to do that, where they can filter out the data and only study the data set, the subset of the data that they're interested in. And by clicking the reset button, we have reset the environment. Again, I can go to filter, click on gender, remove the males, and so all that's remaining is the females. And I can confirm that by coloring and getting a count. And so we can see there are 253 females that we would be working with. And now I can do the same things that we have been doing. I can look at their heights, I can look at their foot length, I can look at their favorite subject area, and many other attributes. Their sleep hours that they get per night, per school night. But we're only looking at a subset of our population, which is just all the females. And if I want to reset the environment, I can reset all the filters. And so you'll watch all all the males come back in, and now I can do my analysis again. And so here it is. We were 451. 451 students chose to input their height. 49 didn't, and so we're only looking at all the data points that actually have a value. And so in this case, we have to ignore the 49 students that are doing this, that decided not to answer and submit an answer to the height question. So basically, let's do a quick review of what we have covered. We've covered how to dot plots. We've covered the 4 different kinds of bar charts. We've covered histogram, stretch bar chart, stack bar chart, and a regular bar chart. We've covered 3 different kinds of box plots. We've covered the regular box plot. We've also covered a box plot that shows you the outliers and the 5-number summary. And we've also seen a box plot that that is embedded on top of the dot plot. So to be able to showcase that in the box plot, anything below quartile 1 is the bottom 25% of the data. anything above quartile 3 is the top 25% of the data, and the box in the box plot shows you the middle 50% of the data. So that's sort of the way to really showcase to the students what the box plot is actually showing you, and you can use the dividers to actually make that point as well, as we saw. We also saw an ability to filter. So we saw how we can remove certain data points. We can remove we can study just the females by removing all the males. Similarly, if you said, okay, well, I only want to look at students that are above the ages of 10. So in that case, let's go back to our age filter and unselect 8 and 9, and now we would, and even 10, and now we would only be looking at students that are above the age of 10 in this case. So the filter works both for numerical attributes as well as for categorical attributes. And we can reset the filters all here. One of the things that we also noticed was we should encourage our students to use the Tuva tools and play with them and explore the data points that they have in different ways. Because if they do make a mistake, or if they come up with a different kind of visualization, then it's very easy to fix it. It's very easy to reset the environment and start all over again. And again, if they're doing science labs, which a lot of students on Tuva will create and visualize the data from the science labs, from the weekly science labs, once they upload the data. And so once they create a visualization in the lab report, they can take a screen, they can download the image that they've created and copy paste it into the report that they would like. We have lots and lots of students doing that. So there's a few more features. There's line graph and a pie chart, and we'll come back to it. But what I want to do is take some time right now and answer some questions that you may have. I noticed that there was a couple of questions that were already posted. So let me expand on that. And so while we're sort of taking a break here for a minute, if you have any specific questions about a specific feature, feel free to input the question in the question tab on the control panel, and we can get to it in a couple of minutes. One of the first things you'll also, when we started off, while we're waiting for some questions, is the About the Dataset. So About the Dataset button will allow you to get a brief description of the data and how many cases there are, how many attributes there are, and how it was collected, what is the source. It's always important for students to know where the data is coming from. And so we've got the source of the data here. We've got a glossary of terms. So in case you are confused, or your students are confused about a specific function on the Tuva environment, we've got a glossary here that we can review. And we also have a tutorial video that will showcase many of the features that we have covered today in terms of creating different kinds of graphs and plots and charts. Okay, so we've got some questions. All right, so let me start taking some of these questions. So Laura has asked the question, how did you get the total number of cases to show up on the chart? Okay, so let's look at that again. So we have a count function that will give you the total number of cases on any chart. So let's again go back and plot let's do the heights. It's simpler. Actually, just to showcase, let's do the ages. All right, so I've got different age categories here. Now I want to get the count of the number of students in each one of these categories. So I'm going to go here to this particular icon, the three lines, go to the count, and then click on count by category. And that gives me the total number of cases for each category, each age category here. In fact, it also gives you the percentage. If I want the percentage, I can go ahead and get that as well. Similarly, if I wanted to do another activity. So favorite school subject. We've done this one, but let's do it again. Here we'll also get the count and the percentages, but they're updated based on the number of students that have indicated their favorite subject area, their favorite subject, and you can see that the counts here. So 48 said history, 70 said mathematics, 33 said music, 46 said English, and so using the count and the percentages right here is the way to get the counts and the percentages for specific categories on your graphing area. So hopefully, Laura, that answers your question. Let me go out and find what happened to the question. Seem to have the other questions. So I can't seem to get to the question window anymore on this panel. But the second question that was asked was around how can students download the graph? So let's do that. So students can download the graph. Not sure why this panel is coming up in the way. The students can download the graph using this feature here. So there is a little camera button here. And so it says download plot as an image. And what we recommend is you always want to label. So here we can label the chart that we're about to download. So it's favorite subject count and percentage from our census survey. So I've labeled my graph, and then I can go back here, I can press this button, and it will allow me to download and save this to my computer. And then I can take that and include it in any document that I'd like to input this in. So that's a very simple way of downloading the graph. And for some reason, I'm still unable to fix my the question panel. So if you have any additional questions, let's figure out how we can get them. We got them back. All right. Any additional questions that you may have from the plots that we have created so far, and some of the features that we have reviewed very briefly? Can it be downloaded to Google Drive? So Laura just asked a question, which is, can I download this to Google Drive? At the moment, it downloads to your computer, and we will have to. If this is something that's important for your students, we will have to look at how we can allow you to save it directly to your Google Drive. It's something that we can look into based on I think we'll have to look at sort of just the ability for students. Are they logged in? Are they not logged in? But so it's a good question. Right now, you're not able to download it to to Google Drive, but it's something that we can look into. Any additional questions, comments? Yes. So what we have not covered in this webinar, just because there's a lot, as you can see, to be able to cover in a 1 hour webinar. But it's really simple for students, for your students and for yourself to upload data on Tuva into your own repository from Google Drive or from an Excel file. So I can show you that very quickly. Once you log in, so I'm going to log in as a teacher into my Tuva account. And once I do that, I'm going to go to the My Datasets tab up top. And here I can import from Google Drive, or I can upload my data from selecting a file from an existing file that I have on my computer. And here we have an example spreadsheet, a Google spreadsheet. So if you click on it, you'll see how how Tuva how you will need to organize your data to be able to upload on Tuva. So it's very simple. The first row and each column will represent an attribute in the first row as such: attribute 1, attribute 2, attribute 3, attribute 4, attribute 5. And then you can have each row representing the data that you've collected. And if it's in this format, then it's very easy and very simple to just press one button, log into your Google account, Google Drive account, find the data set, and upload it immediately to Tuva. And so once it's there, it will be made available right here. So for example, here is experimental data from a lab on gravity that students, that this is sort of a sample data set, but this is from the lab that they have done. And now I can, again, use the Tuva tools to be able to study this data set about the height of the bottle and the entire lab that I did around measuring the gravity and seeing if mass has an impact on gravity. So this is a physics lab, and students were doing an experiment to see how and if mass of an object has any impact on the gravitation on gravity and the time it takes for it to hit the ground. So a really simple, really powerful lab, and lots of students are able to use the Tuva tools to be able to upload their data and visualize it and really be able to understand what the data is saying by exploring the different visualizations, and then be able to create a graph that they could include in the report. Any additional questions from the participants regarding any of the data points, any of the data tools, any of the data sets that we have created, that we've gone over today? If you're teaching math, lots of math activities. If you're teaching science, we're adding more and more science activities every week, adding more and more science and GSS aligned science data sets every week. So lots and lots of new data sets and activities aligned to the different standards are being added on Tuva. So if you have any other suggestions, if you have any questions, if you have questions about Tuva collections, I think we went over that briefly on the last webinar, but I can showcase a little bit of what Tuva collections is about. So Tuva collections are a group of activities around a specific topic. So we've got right now 4 collections, primarily using census data or other authentic data. So this one is looking at historical US history events, looking at things like Civil War, like the Cuban migration, like the California gold rush, and many, many other topics using the census data. So it's a great way to give your students an opportunity to really get a critical view of the different history topics that they'll be learning in their US history class. So the Signs of Change is a collection on that. We've got a wonderful set of modeling activities for teachers who are teaching modeling. So being able to, we did a simple activity on earlier, but being able to figure out what's the independent variable, what's the dependent variable, create a model, and then use that model to make a prediction. Very important set of concepts for students to understand. And so we've got almost 6 or 7 data sets on different things where students get an opportunity to really learn about modeling. And these are all the activities are scaffolded from easy to difficult. So it's a wonderful set of activities. This particular initiative we're working on with the school network, Democracy Preparatory Charter Schools here in New York, which is our civic literacy. This whole set of activities is giving students an opportunity to look into social justice and civics issues in our society here in the United States, looking at race, looking at education, looking at income, looking at immigration, and looking at these topics through the lens of data. Again, very powerful set of civics activities, again, using data that are just really engaging and really sort of real life for the students, because they can relate to it. They see it in the news every day. They hear about it. They're living it on a day-to-day basis. And then this particular one, on employment in New York City. This is a series of activities that we developed in collaboration with the New York City Department of Education. Again, giving students an opportunity to look at an issue of employment. For many students who are thinking about their careers and thinking about college, thinking about their career goals, this is an opportunity to look at employment in New York City through different lenses, including the borough, the race, the attainment, the gender, and a variety of different factors. So we've got a number of different collections that these are available to our Tuva Premium customers, and we're adding many more in the coming weeks and months as well. So keep an eye out for some of the latest Tuva collections that we'll be releasing soon as well. So Laura has one last question. Do you have any activities on Pi? So Pi, yes, we do have a lot of activities on, I don't know if you mean the Pi graph or the number Pi. We do have some activities on the Pi graph. If you're looking for activities on the number Pi, I'd love to have some more information around them. And you can always reach out to us on support@tuvalabs.com or hello@tuvalabs.com to be able to, we're happy to answer any questions regarding activities. You can search using the search function up top as well, and happy to sort of send you additional information about specific activities that you're looking for, based on the needs of your students and your teachers, if you're working at the district level, which I know many of you are. So with that, if there's no other questions, then, as I said, we'll be running this particular webinar on how to use the Tuva tools. Again, as you can see, they're incredibly powerful, very easy for your students to use, and really it's about playing with the data, creating different visualizations, taking a moment to observe what you're noticing, and really getting a feel for how do I ask the right questions that the data can help me answer. And so we're releasing a number of activities, number of tools, number of PD resources aligned to science standards, aligned to the Common Core Math standards, to help you really think about the data and the measurement and the critical thinking and the number of different practices that we have to help our students learn. So that's really the goal and for our K-12 solutions. So if you have any additional questions, please don't hesitate to reach out to us. hello@tuvalabs.com. You can reach out to us on Twitter. You can reach out to us on my email as well. So happy to answer any questions if you have. Otherwise, we're hitting an hour at this point, so we'll be ending the webinar soon. Feel free to reach out to us at any point, and we'll be happy to answer any questions that you have.